Okay, welcome everyone to this presentation where we want to look at LU factorization or decomposition. Usually it comes under this course, numerical, linear algebra, and approximation. Sometimes it's just numerical analysis. If it is undergraduate, it is numerical analysis in most of the universities, all right? So want to see how we can deal with the LU factorization or decomposition. So I'll pick a question from this paper. Okay. I'll pick a question from that paper. Okay. Where is the question? So okay. We are saying this is our question. Okay. This is the question. Find, okay, so the question says find the find an LU factorization of the given matrix of the matrix A is equal to the first row is 5, 3, 5, 2. And the second row is 0, 8, 2. Then the third one is 6, 2, 8. Okay. So solution. Now, LU factorization is the same as LU decomposition. Okay. So to come up with an AU factorization of A, this means that we need to express A as a product of the lower matrix and the upper matrix. Okay. As a product of the lower matrix and the upper matrix. Okay. Now, there are a lot of ways that we can use to do that. Okay, so there are a lot of ways that we can use to do this. Okay. Now, what is the lower matrix and what is the upper matrix? Now, and a lower matrix, actually it's not just a lower matrix, but it's a lower triangular matrix. So we are saying, note that L implies lower triangular matrix, okay? Which can be written as L is equal to, maybe we say L1, we have got 0 here, 0 and another 0 here, okay? Then, actually for a shortcut method, with this lower matrix, here we have 1. There are a lot of procedures, but this is, I think it's a shortcut. Here there should be 1, and there should be 1. Then we need to find, I can call it L21, then L31, L32. Okay? So you can see clearly from here that we need to find L21, L31, L32. Once we do that, we'll have come up with the lower matrix. Okay. Then this U, it is the upper triangular matrix. Upper triangular matrix. What do we mean? If you look at the lower triangular matrix, we want to have a triangle here below here. Okay. Want to have this triangle here. That's what we mean. Then the upper is the opposite to be above. So what this means, therefore, is that for the upper triangular matrix, we can have, maybe I'll call it U11. That is the first row, first column. U12 can also have U13. That is for a 3 by 3 matrix. Okay. Then here, we need to have 0 here. We need to have 0 here. We also need to have a 0 here, meaning that these 3 are non-zeros. Okay. So we are going to have, this is the second row, we'll say U22. Then U23. Then we'll have U33. This is what we have, such that when we multiply these two, they must give us the first matrix. Now, what is important is to deal with or to come up with the upper matrix, and take note of the way you're going to deal with the row operations, okay? Because we are using a shortcut method, and from the row operations, we are going to come up with L21, L31, and L33. Then we do the replacement. Now, we have this matrix 3, 0, 6. Okay, 5, 8, 2, 2, 2, 8. So we are going to execute a process of coming up with the upper triangular matrix. Don't worry about the lower one, but whatever we'll be doing will help us to find the lower triangular matrix. Okay. So now, like we said, for the upper triangular matrix, we have to make sure that this is 0, this one is 0, and this is equal to 0. Okay. Now, we'll start. If you look at the second row, the first entry there in the second row, it is already 0, right? So it means we do not need to do any multiplication whatsoever, any row operations whatsoever, because there is already 0. So it means we are saying, since the first entry in the second, or we just say row 2, row 2 is 0, it means we will not do any multiplication. We'll multiply by 0. Okay, in other words, will not do anything. So it means because this second entry here, for the upper triangular matrix that we want to come up with, will correspond, whatever value that we are going to use to multiply, will correspond to L21, provided we swap the signs. But since it is 0, even if you swap the signs, so it means L1, L21, okay? So we are saying this implies that L21 also be equal to 0. Okay. Next, we come up with a 0 here. Okay. So now, how do we get 0 here? So that is the row 3. So I'm going to say row 3 will be found by multiplying this row 2 by negative, row 1 by negative 2. So negative 2 row 1 plus row 3. Now, because I've multiplied this row 1, or indeed another row, by negative 2, and this is on what? L31. Here, L31, okay? It means, straight away we can say, this implies that L31 will be equal to, instead of negative 2, the one that we have used, we'll just maintain 2. Okay, then we continue. So we'll rewrite the matrix. This implies that we'll have 3, 5, 2, 0, 8, 2. Then when you multiply negative 2 by 3, that is negative 6 plus 6, get 0. Okay. Then negative 2 by 5, that is negative 10 plus 2, we get negative 8. Okay. Then negative 2 by 2, that's negative 4 plus 8, we get 4. So this is what we have. Okay, and we're almost done. See, it's a shorter method. Then we need to produce a 0 here. So here we are trying to create an upper triangular matrix. In the process, we are also getting the lower triangular matrix. So now, what do we do? So we are going to say row 3 is equal to row 3 plus row 2. Okay. If you want, it's like here, you're multiplying by 1, in case you can't see. Okay. So the coefficient here is 1, or the scalar here is 1, positive 1, implying that this is now A32 at this position should be negative 1, the opposite. Okay. Then we'll say this implies that we'll have 3, rather, I don't know why I keep on saying 5. 5 now, 2, 0, 8, 2. So now, if we apply this, so you add 0, you still get 0. You add this, you get 0, which is what we wanted. Then when you add 4 plus 2, we get 6. And this is your upper matrix, triangular matrix. This one is our U, which is the upper triangular matrix. Okay, so it's a shortcut. But what is our lower matrix? Our L. Remember, we said our L from, if you can go back here, This is our L. 1, 0, 0. Okay. Then the diagonals there, we have 1. So maybe just I can write. We said our L is 1, 0, 0. Then here we said this is L2, 1. Here it's 1. Okay, here there's 0. This is L3, 1. L3, 2. And here there is 1. Okay. This is what we have. But we found L2, 1. What did we get? To check above here. L2, 1 was 0. Okay. We found L2, 1. We equally found L3, 1. We indicated that it was 2. And we also found L3, 2 as negative 1. So we just replace, we just do the substitution. Therefore, our lower triangular matrix is 1, 0, 0. Where there is L2, 1, we put 0, 1, 0. Where there is L3, 1, we put 2. Then where there is L3, 2, we put negative 1 and 1. And therefore, this one becomes our lower triangular matrix. Therefore, or hence, what do we have? We have our original matrix. Maybe I write it here. We have 3, 0, 6, 5, 8, 2, 2, 2, 8. We should express this as a product of the lower triangular matrix and the upper triangular matrix. So 1, 0, 2, 0, 1, negative 1, 0, 0, 1. Okay. Then what is our upper triangular matrix? Our upper triangular matrix is 3, 5, 2. 3, 5, 2. We also got 0, 8, 2. Then 0, 0, 6. This is our LU factorization or LU decomposition. Okay, this is where we end for this presentation. Please subscribe to our channels. You can also subscribe to Kanban phiri-JM. If you want to contact us, on 097 856 58 76, 097 967 3809. We also have GCE lessons for 2025. Please contact us today. Till next time. Bye-bye.